Okay, here we go with Chapter 3, Lecture 2. In this lecture, we will cover the different structures of the brain, different sections of the brain, hemispheric laterality, right and left hemispheric function, and we'll also talk a little bit about the endocrine system. So, let's first start with how we divide the brain up. Now, in your book, I believe this is image 3.5 from the text. If you look at it, the brain here is actually divided into three different sections. Your book talks about the forebrain and the hindbrain, and oops, what did I do? I didn't do the right thing. There we go. The forebrain and the hindbrain and etc. We're going to do a much easier way of dividing the brain into different sections. Okay? This is the method that was used by Alexander Luria, a well-known Russian neurologist who divided the brain into three sections. The brain stem, which is this set of structures right here. The midbrain, which is this central set of structures right in the middle, and then the cerebrum, or cerebral cortex. And then there are a couple of other structures that we'll talk about individually. So, let's start with the brainstem. Here's the brainstem right here. There are three major structures in the brainstem. There is the medulla, the reticular formation, and the pons. Okay? So let's try it this way so that it'll stand up and you can see it. All right. So the brainstem right here, that keeps us alive in the very moment you are at this moment. Okay? This portion of the brain stem, way down here, this is actually in the spinal cord. So a portion of your brain goes down into the spinal cord. As I said, the brain stem keeps you awake right now. That means that the fact that your heart is beating and the fact that your lungs are breathing, those two facts are caused by the brain stem. Now let's talk about that a little bit. First, we have the medulla. This is this portion right here, not the shaded portion, but the unshaded portion about halfway up. Little bulbous section right here. That's called the medulla. Made popular by Adam Sandler is the medulla oblongata. So, the medulla sends constant stimuli to your lungs and your heart. Every time your heart beats, the medulla is sending a stimulus to your heart. Every time your lungs breathe, the medulla sends a stimulus to your lungs. Every single time your heart beats and your lungs breathe, the medulla sends a stimulus. Now, the medulla doesn't determine how fast that will happen, whether it's a rapid heartbeat or rapid breathing. But it does actually send the stimulus that causes you to be alive in this very moment. This next structure above the medulla, the kind of bulbous thing that sticks out right here, that is the pons. The pons helps the medulla, does do some of what it does. It helps with heartbeat and respiration. It also helps the reticular formation, which is this shaded portion of the brainstem, up and down the entire length of the brainstem. That's called the reticular formation. It also helps the reticular formation do some of its job. So the pons kind of helps both of the other structures do what they do. Now the reticular formation is your 24-hour biological clock as it relates to sleep and wakefulness. So if you wake up at a certain time every day, that's because your reticular formation is, should we say, programmed to get you up at that time. And if you start to get tired at a certain time every night, well, your reticular formation is what tells you that you're going to get tired. So the brainstem, if you really think about it, it's all about arousal. Sleep and wakefulness arousal, heartbeat, respiration arousal. It arouses our system. Okay? That is the brainstem. Now we have the midbrain. That's these structures right in here. Let me open it up some more. See if it'll get a little bigger. It only gets that big. Maybe it'll get a little bigger this way. Uh-oh. Lost it. Nope, wrong way. All right, the midbrain also keeps us alive, but it keeps us alive in the long term, the much longer term than the brainstem. Now there are a host of structures. That might be a little bigger right there so you can see it a little better. But like I said, this right here is the midbrain. Okay? The central structure, this great big bulbous structure right here in the middle of the brainstem, or of the midbrain, is called the thalamus. The thalamus is your communications center. It's the part of the brain that receives information from the spinal cord. It goes up to the thalamus, and then the thalamus directs information to higher portions of the brain, out here to the cerebrum, which we also call the cerebral cortex. That's what it does. And information that needs to go down to the body from the brain will come down from different areas in the cerebral cortex down to the thalamus, and then the thalamus directs that information down into the brain stem and further down into the spinal cord to then go out to the body. So, if you could imagine how damaged someone would be if they had a stroke in their thalamus. This is something that's important to understand. A stroke is a cardiovascular issue in the brain. That means a burst blood vessel, a ballooned blood vessel, like an aneurysm, or a clot, a blood clot in the cardiovascular system in the brain. Anything that either keeps blood from getting to a portion of the brain or causes blood cells, especially red blood cells, to come in contact with neurons, because blood cells are actually toxic to neurons. Neurons die when they're exposed to blood cells. When a stroke occurs, it inhibits some function of the system. Usually they're more to the periphery or to the outside of the brain, which would be further out here in the cerebral cortex. But when they're more central, they affect a greater extent of functioning processes. And that's important to understand. The more central a stroke, the more damage that occurs, because the more central, the more things are connected to other things. The more to the periphery, the less global the effects of a stroke would be. No, I'm not minimizing in any way the effects of a stroke on the outside of the brain. They all are very distressing and very difficult for people, but they are worse the more central they become. So that is the thalamus. Underneath the thalamus, up here to the front, is the hypothalamus. That's this extension right here, coming right down from the bottom of the thalamus and down here. That is the hypothalamus. Now, off the end of the hypothalamus hangs the pituitary gland. This is the pituitary gland right here, this little white thing hanging down. The pituitary gland is actually not part of the brain. It hangs off of the brain right at the hypothalamus, but it's not considered part of the brain. But it's important that it hangs off of the hypothalamus. Most people think that the hypothalamus manages the entire endocrine system, the glands of the body, but it does not. It's simply the foreman. The hypothalamus carries out the orders of the hypothalamus. So the hypothalamus is really is the brain structure that's in charge of the endocrine system. And the pituitary gland is the master gland. It tells other glands what to do, but only from the direction of the hypothalamus. Now, the hypothalamus has 4 major functions. Its 4 major functions are hunger management, thirst management, temperature of the body, management of that, and all sexual function. So it's a busy little portion of the brain. When we talk about hunger and thirst, if you're feeling hungry, it's because your hypothalamus is telling you you're hungry. And if you're feeling full after you've eaten, that's your hypothalamus telling you that you're full enough. The same thing with thirst. If you're thirsty, speaking of thirsty, your hypothalamus is telling you you're thirsty. And if you've had enough liquid, then your hypothalamus is telling you, okay, you're no longer needing fluid. Temperature control, meaning if you shiver and get goosebumps, your hypothalamus is telling your body to do that. If you're sweating because you're doing physical activity, that's because your hypothalamus is telling you you're doing that. Okay? And all sexual function. So all actual sexual drive, the functioning of the body, the sexual functioning of the body, the human sexual process is all controlled by the hypothalamus, and all of the maturation of the body, from a non-reproductive being to a reproductive being, is all managed by the hypothalamus. So, that's the hypothalamus. Then we have the limbic system. The limbic system is a lot of the midbrain. In fact, it includes everything in the midbrain. The midbrain, here you've got the thalamus, you've got the mammillary bodies, you've got the amygdala, you've got the fornix that stretches over the top here, you have the thalamus, the hypothalamus. All of those structures are part of the limbic system. The limbic system produces all of the excuse me, all of the physiological reactions that are necessary for emotion to occur. Now, the limbic system is connected with the frontal lobe, which is right up here. you have to have frontal lobe function as well as limbic system function to experience an emotion. What does that mean? Well, you ever heard of a frontal lobotomy? A frontal lobotomy simply means that, oh goodness, did I point to the right place? Yeah, I did. Okay. The limbic system is connected with a neural bundle, a big nerve that goes from the frontal lobe directly to the limbic system. And years ago, when people were overly expressive because of mental illness, now this is back in the early 1950s, for about a year, a psychiatrist traveled throughout the country and performed frontal lobotomies, where they would insert a sharp device right here to the side of the eye, up into the brain, and then they would sever that connection between the limbic system and the frontal lobe, and the person would literally turn into an automaton. They had no emotional expression at all, because the frontal lobe is where all the thinking occurs, the reasoning. And the limbic system is where the physiologic arousal occurs that is associated with emotion. If we don't have physical arousal, we don't experience an emotion. And so when that was severed, there was, when that was severed, there was no emotional response after that. Okay? So, the limbic system is all about the expression and management of emotion, specifically the physiological parts, the increase in heart rate, the increase in respiration rate, the increase in muscle tension, the increase in blood pressure, the increase in flushing of the face, etc., that is all associated with emotion. Well, that's pretty much the midbrain. Also, deep here in the midbrain, this little, and you'll see it on your picture in the book, is the amygdala, this little tiny bulbous thing. The amygdala is where all of our fight, flight, or freeze reactions occur, specifically anger associated with fight, and freeze. So it's an important part of the midbrain, but specifically also an important part of the limbic system. Okay, now we have the cerebral cortex. If you look, the cerebral cortex is all this squiggly stuff that has all the folds in it on the outside of the brain. Now recognize this is the brain sliced in half, up and down. Okay? You're looking at the left side of the brain as it's been sliced right down the middle. Let's see. The cerebral cortex, as you can tell, covers the majority of the brain, and about 2/3 of the mass of the brain is made up of the cerebral cortex. The cerebral cortex is divided into 4 different lobes. Now, the term lobe refers to just different sections of the brain. I'm going to show you image 3.13 in your book. And this will show the 4 different lobes. Oh goodness, what did I just do? There we go. Can't touch these stupid iPads the wrong way. Okay. These are the 4 lobes of the brain. By lobes, again, we mean sections. Now, this portion right up here to the front of the brain is called the frontal lobe. Now, there are 2 frontal lobes. There's a left frontal lobe, and then there's a right frontal lobe on the other side. Excuse me, this is the right. So there's a right frontal lobe and a left frontal lobe. The frontal lobe has numerous functions. I'll give you just 3 of them. One thing the frontal lobe does is reasoning. We have tiny little spots all over the cerebral cortex that are called association cortex. And when we make an association, we connect two ideas, we connect two things, we connect two people. An association is when there's some connection between stimuli. The lobes, the frontal lobe has the great majority of that association cortex, and associations are the foundations of thought. So therefore, you've got the frontal lobe doing the majority of your reasoning or the majority of your thinking. Excuse me for just a moment. I've got to close the door. Here we go. All right. The frontal lobe also manages your emotion. Remember we talked about the midbrain and the connection between the midbrain and the frontal lobe? Well, you have to have two things for emotion to occur. You have to have physiological arousal and you have to have cognitive interpretation of whatever event is occurring for emotion to happen. And as we said, the midbrain creates that physiological arousal, but the frontal lobe is what manages the emotion, what controls the emotion. So when someone's angry and they have a boundary that they don't cross because of their anger, that's the frontal lobe making that happen. Third thing the frontal lobe does is, if you see this little bluish, purplish strip that comes down at the back of the frontal lobe, that's called the motor cortex. All of the motor function of your body is controlled by that motor cortex. So if you make a voluntary movement, you lift your hand up in the air, a little place right along that motor strip is going to be fired up and telling your arm what to do and how to go about doing it. So those are the three major functions of the frontal lobe. Now, as we go back a little further, you see this green strip right here. This green strip, and then the processing portion of the brain behind it is called the parietal lobe. The parietal lobe is all about sensation. It receives all of the information that comes to your body from your world, sensation, actually the sensation of touch, temperature, pressure, pain, all of those sensations come to up the spinal cord and go to the parietal lobe. And the parietal lobe then shows you where certain parts of your brain are functioning, or certain parts of your body are functioning along that strip. Now there's another image that I'd like you to see that shows how the parietal lobe is divided up. Here, make it a little smaller, a little further that way, there we go. Okay. Right here, you can see this is one side of the brain, down here, coming down like this. That's one side of the brain, along that parietal lobe. And you'll see what portions of the body are made up of that parietal lobe. Now, if you look at it closely, look how much of your parietal lobe is made up of portions that receive stimuli for your face, and this is motor function also, and for your hands. Look how much of your body is used up there. And then we have the torso and the arms and legs here, which is relatively small compared to the hands and face. And then literally the rest of the body down here. So that's what the parietal lobe does. It receives information like this. This is actually depicted in the book as the motor strip, but the motor strip and the sensory strip are divided up relatively the same. Okay, that is what your parietal lobe does. It manages all those functions. Next is the occipital lobe. The occipital lobe is right back here in the back of your brain. That occipital lobe is all about vision. All of your vision is managed and controlled by the occipital lobe. So your eyes are divided right down the middle, and you actually have two optic nerves coming out of the back of each of your eyes. One takes up all of the information from the right side of each eye, and one from the left side of each eye. And all that information gathers and goes back through the optic nerve into the brain, and then they cross. Where they cross, and your book actually has a good image that you can look to see that, at the optic chiasm, in which information from the right side of the brain is sent to both the right and left occipital lobe, and information from the left eye is sent to both the right and left occipital lobes. So both occipital lobes, both the right and the left sides, are receiving information from both eyes, which is actually what permits you to see things in 3 dimensions, because each eye has a slightly different view of whatever object it is that you're looking at, simply because it's on different places on the face. Let's see. Literally, you can find a tiny little place on your retina in the eye, which is that inner bladder of the eye that coats the inside of the eye, through which and then you see through fluid. That information, if there's a shining light that goes to a specific spot on that retina, you can see that specific spot shine up bright as day on an MRI on a specific place on your occipital lobe. So it's that specific. And then finally, we have the temporal lobe. This is the temporal lobe right here. Okay? Temporal lobe has 2 major functions. The one major function is hearing, which makes a lot of sense to me, which also says that vision doesn't make a whole lot of sense. Why are the eyes all the way up here and the processing of visual images is all the way back here? That just seems to me inefficient, but nobody consulted me on that. But on the other hand, here is where in your brain you process all auditory information that comes in through your ears. That's the first function of the temporal lobe. The temporal lobe also has a significant function in memory. All of our memory must go through the temporal lobe before it's stored anywhere else in the brain. And so if the temporal lobe isn't functioning correctly with short-term memory, then you won't have much short-term memory. Then you won't have much long-term memory, I should say. So that is, those are the major functions of the temporal lobe. Do all of those lobes of the brain have more functions than just that? Of course. But they all do their part separately. Okay, now there are 2 other structures that I want you to be aware of that don't necessarily fit into all of these 3 different areas that we've talked about: midbrain, brainstem, and cerebrum. The first is the cerebellum. This is the cerebellum right there. It's right at the base of the skull in the back. The cerebellum is where all balance and coordination of the body and the body movement occurs. So the fact that you can heel to toe step with your foot, that is a cerebellar function. The word cerebellum means little brain, and if you look at it, it looks like a little brain. It's an entity unto itself, all there at the base of the brain. It even has its own cortex on it, if you look closely. And so it's kind of a separate entity from the rest of the brain. Interestingly, the cerebellum is the first part of the brain to receive toxins from the body. That little scream you're hearing upstairs is my little granddaughter. You will always be able to remember that you heard my little granddaughter scream. There is a picture of the cerebellum from the inside, right here. Okay? And as I said, all coordination and balance occurs. And so therefore, if someone has imbibed too much of the demon alcohol, the first place it goes to is the cerebellum. And what does the cerebellum do? Balance and coordination. Therefore, someone cannot know in their frontal lobe that they're inebriated yet, but their cerebellum is already well under the influence. Now we think in our frontal lobe. Therefore, it would be good if we thought at the same time that this portion of the brain was being poisoned. Okay? That's the cerebellum. The other structure is this whitish structure that goes all the way across right here. And what is that? That is called the corpus callosum. The corpus callosum is where the two sides of the brain are connected and information is sent back and forth between them. So that way, right and left sides of the brain all can function together. Let's talk a little bit now about hemispheric laterality. Now, there are some other structures in the book. You probably want to look through them, be familiar with them. The basal ganglia, some others that you'll probably need to know. These are the ones that I think are most important, but you'll need to know them from the book either way. Hemispheric laterality has to do with right and left sides of the brain. The right side of the brain and the left side of the brain have separate functions. Now, can the right side of the brain and the left side of the brain do the same things? Well, yes, they can. Oops. Dang. Right side of the brain and left side of the brain. So the right side of the brain can do left brain functions, and the left side of the brain can do right brain functions. But the right side does right brain functions better than the left, and the left side does left brain functions better than the right. So what are some of the left and right brain functions? Well, the right side of the brain, and of course, here's the front, here's the front of the brain. Here's the two eyes, okay? And so this would be the left side of the brain, this would be the right side of the brain. And this image here is explaining how information from both eyes go to both occipital lobes back here, as I mentioned to you earlier. But left side of the brain, what are its major functions? Language. One of the structures in the midbrain is called the hippocampus. The hippocampus is where all of our short-term memories are stored. And from there, all of that information goes to other places of the brain. Well, the left side of the brain is where the hippocampus generally resides for most people. So, memory has a lot to do with language. There are two structures. One is called the Wernicke's area, which is right up here on the side, and the other is called the Broca's area, a little further from it. The Wernicke's area is where all of our words are stored. The Broca's area is part of the motor structure of the brain, so it's mostly the frontal lobe, a little bit the temporal lobe too, because that's where the words are stored away. And that's for most people in the left side of the brain. You'll find a few people, they have Broca's and Wernicke's area on the right side of the brain, but for most people it's left. So language is very much a left brain function. Analytic thought, detailed thought, linear logical thought. If A equals B, if B equals C, then A must equal C. Those are all left brain functions. That's what the left side of the brain tends to be mostly known for. Now, of course, the right side of the body is controlled by the left side of the brain, and all of the sensory information from the right side of the body goes to the left side of the brain. So that's a little different there too. Now, the right side of the brain. The right side of the brain is more associated with emotion. The right side of the brain is more image-based, your visual spatial reasoning. Remember, the left side of the brain, linear, logical, mathematical kind of reasoning is left side of the brain. The right side of the brain, imagery reasoning. So being able to look at your world and make sense of your world is a right-brained function. As I said, emotion. Also, the right side of the brain is where most creativity exists. It's where most artistic abilities come from because of that visual spatial reasoning that is right brain function. All of them. So those are some of the basic differences between left and right side of the brain. You'll find some more divisions in the book, but these are the basic ones. Okay. Let's now take a look at the endocrine system. Here is your endocrine system. Now, as you can see right at the top, that's where the hypothalamus is. Let's expand this. I lost it. What did I do? Come on, get back to where you were. Darn it. Well, I lost it. It's going to take me too long to find it right now. Let's see. Maybe I can find it pretty quick. Here we go. Chapter 3. Yeah, there we go. Okay, so there are major glands in the body. We already said that the hypothalamus is the boss. The pituitary gland is the foreman. It does what the hypothalamus tells it to do. Okay, there it is. Let's see if I can keep it here this time. All right, we'll move this up a little bit. You can see the whole thing. Let's try to expand it just a little more. There we go. Okay, so up in the brain, you have, let's not worry about the pineal gland. It's not really a gland. It's actually just a brain structure, but it's part of this process, but it's associated with the hypothalamus. And then under the hypothalamus, right up here that we saw before, the pituitary gland hangs off. Now recognize the hypothalamus has nervous system connections with every one of the glands in the body. Nervous system connections with every one of the glands in the body. The pituitary gland only has cardiovascular connection with the other glands of the body. So it can sense what hormones the other glands are putting out in the body through the cardiovascular system, as well as the other glands in the body can sense what hormones the pituitary gland is sending out into the rest of the body through the cardiovascular system. Now, at last count, there's either 11 or 13 different hormones that the pituitary gland releases. These are just experts differing on whether or not It's 11 or 13. But there's a bunch of them. There's growth hormone. There's FSH, follicle stimulating hormone. There's luteinizing hormone. There's a whole bunch of different hormones that the pituitary gland releases to tell other glands in the body what to do, of course, under the instruction of the hypothalamus. So that's the pituitary gland up here in the brain, hanging off the bottom of the brain. Down here, we're only going to talk about the thyroid gland. What does the thyroid gland produce? Thyroxin. And what does thyroxin do? Thyroxin tells the body how quickly to use up its stores. So high levels of thyroxin means that people are going to be skinny. Low levels of thyroxin mean they're hypothyroidic. That means these individuals are probably going to put on more weight and not have a lot of energy. Actually, it's one of the things we have to rule out before we say someone's depressed is the functions of the thyroid gland with its thyroxin. We have a dog, a golden retriever, who since she was a year old has been hypothyroidic, and we have to give her levothyroxine every day. That's not a very uncommon thing, a very uncommon disorder for people to have, and it can be managed quite well through thyroxine medications. You go down a little further and you run into the adrenals. And what chemical do you think the adrenal glands produce? Yes, adrenaline. Adrenaline is used to increase or decrease physiologic function based on the amount there is in the system. When the adrenals get all messed up, people either lose or have excessive amounts of energy, and that can be quite problematic. Underneath the adrenals, we have the pancreas. The pancreas produces insulin. What does insulin do? Insulin is actually a necessary chemical that must be in every cell for the cell to break down sugars and obtain energy. So low insulin means that a person is hypoglycemic or diabetic. Excessive amounts of insulin can also be very damaging for an individual too. Finally, we go down to the sex glands. In the males, the testes, and the females, the ovaries. The testes produce 2 hormones. The ovaries produce 3. The testes produce testosterone, of course, and the testes also produce a small amount of estrogen. What does testosterone do for a male? Well, all of the primary and secondary sex characteristics that occur when a male develops from non-reproductive to reproductive status. The primary characteristics are those that are specific to the genitals and therefore cause reproduction. The secondary characteristics are all of the other body shape and hair growth and voice change, etc., changes that occur in that maturational process. Also, the testes govern all sexual function, the human sexual response cycle in males, and they also create all sexual drive in males. The ovaries produce estrogen and progesterone, but the ovaries also produce a little bit of testosterone. For females, testosterone is the chemical that causes sexual drive. Estrogen is the chemical that does the other 2 functions that testosterone does in males, specifically primary and secondary sex characteristics, as well as it manages all of the human sexual response cycle in females. Progesterone is the chemical that keeps a woman pregnant. If when a woman ovulates, there's no progesterone being produced right at that time. Toward the end of the ovulation period, if fertilization of an ovum has occurred, then the ovum, when it begins to embed into the uterine wall, it will cause the production of a specific chemical, which chemical communicates to the ovaries that it needs to produce progesterone. And progesterone is the chemical that keeps a woman pregnant. So as the progesterone continues to be produced throughout the course of the pregnancy, then the woman remains pregnant. At birth, progesterone is discontinued, and therefore that lack of progesterone stimulates other chemical processes that will then contribute to the birth of the infant. But that's what progesterone does. So if the ovum is not fertilized, then no progesterone is produced, or no excessive progesterone is produced, therefore binding the ovum to the uterine wall, and the ovum is sloughed off in menses. So those are the functions of the endocrine system. Do you think those endocrine system functions could look like a whole lot of psychological disorders if there were excessive or lack of amounts of those different hormones in the human system? Well, of course, they could look like a lot of disorders. That's why we have to know what an individual's hormonal levels are before we can truly say that an individual is suffering from a specific psychological disorder. Okay, well, that's the end of the information on Chapter 3. In the next day or two, I'll be posting lectures for Chapter 5, and your Chapter 5 module will be up. But work on your Chapter 3 module now. As I mentioned earlier, back in the orientation, we will not be going through Chapter 4. We will skip to Chapter 5. And good luck on the assignments for Chapter 3, and I'll be looking to see them. Thank you very much, and we'll talk to you later.